Hi guys, welcome to Plain Trigonometry for summer 2020. My name is Sarah Schatz and I will be instructing this class. I'm going to be putting up video lectures of each section that you see in your ALEKS homework. So as we do this, as you come up to a new section, these videos will be posted through D2L. So you'll go there, find the section, you can watch the video, and then you can do the homework. If you don't need the videos, especially like on a geometry review, you might not need to watch the video, but they're there for your reference if you need. So let's get started. The first section you see when you start your homework is a geometry review. Basically, we want to make sure you remember how to use the Pythagorean theorem and know how to apply it to certain special types of triangles. So I'm going to go over that with you and do a couple of examples. So we know that the Pythagorean theorem applies to triangles that are right, so they have the right angle. When we're talking about the theorem, we talk about the sides that make up the right angle as the legs, and then the long slant side is the hypotenuse. Usually we use A, B, and C to label the sides of the right triangle when we're using the Pythagorean theorem. So that's what I'm going to do here. We'll definitely see different variables, but for the teaching, we like to use A, B, and C. Now, it doesn't matter which leg is A and B, but the legs are A and B, and the hypotenuse is always C. So I'm going to call the bottom leg A, the side leg B, and then the hypotenuse will be our C. And if this is true, then we know, per the Pythagorean theorem, that A squared plus B squared always equals C squared. So this is something that you've seen before, definitely. You guys, some tips about it if you haven't used it in a while. The hypotenuse is always on the side by itself. So we're going to come into some problems where maybe the hypotenuse is one of the things we know, and we like to put our things we know sometimes together. But if it's the hypotenuse, it has to go on the side by itself. So legs together on one side, hypotenuse always alone. Also, the order of operations is going to come in here, and as we work out a problem, I'm going to make sure we get all the steps in the right order. So we've got this down. Let's work an example. Okay, so in your ALEKS homework, you're going to find some really straightforward examples of applying this theorem. So for number one, I'm pulling this straight from the homework, so you'll see a problem probably very similar to this, probably with different numbers. But we've got a right triangle, and it's drawn out for you on your homework problems. I know that the bottom leg is 10, this side leg is x, which means we don't know what it is, and the hypotenuse is 16. So notice they're using x here instead of a or b. And like I said, especially in ALEKS, they like to play around with variable names. It helps you get used to being able to use multiple different kinds of variables. So we are looking for x. So with these being the two legs and this being the side, I think about my a squared plus b squared equals c squared. Now, again, usually I use the bottom value for a. So when I put in a, because I know a, I'm going to call that 10. Now, the b squared that's usually here is this leg. I still don't know what it is, but I am going to put in an x for that value since the variable in our problem is an x. So I'm going to say we have 10 squared plus x squared equals the hypotenuse, which is 16 squared. So we've got our equation set up. We do need to solve for x. This is where order of operations is really important. We do need to square all of these values before we go any further. So 10 squared is 100 plus x squared, we don't know what that is yet, equals 16 squared, which is 256. So we're here. Remember, your goal is to isolate the x term since we're solving for that. So I'm going to subtract 100 on both sides and get that x squared equals 156. After this step, we do have to square root both sides. Remember, your goal isn't to find x squared, your goal is to find x, find the missing side. So I need a little more space. So I'm going to go ahead and erase my triangle. And we're going to go over here, taking this line up to here. I'm going to square root both sides. So the square root of x squared is x. The square root of 156, I'm going to leave that for a minute. When you take a square root, I know that technically we always have to consider the plus or minus root. But when we're looking for sides of triangles, which are definitely positive, I don't have to think about the minus. So really, I know it's going to be just the positive square root of 56. Now, where I go from here depends on how the question is worded. In your homework questions, it wants you to round. So it says round to the nearest hundredth on this question that I have pulled up, which means that is just going to your calculator, typing in the square root of 156, and rounding it to the nearest hundredth. So I'm going to do that here. So I get 12.49 rounded to the nearest hundredth. You guys, if you're ever working a problem, and we will have problems where your answers need to be exact, we would have to leave it in the square root. So leaving it in the square root means that this is an exact answer, otherwise not rounded. This is a rounded value, so it's not technically exactly the same as the square root of 156. But because the problem asked for a rounded value, that's what your answer is going to look like. Now, while you all probably feel really comfortable with the Pythagorean theorem, because I'm sure you've used it before, probably in geometry, what you might not feel as comfortable with, or you might not have really gotten into in a geometry class, is the special right triangles. So, what I mean by special right triangles are triangles that have certain relationships between their angles. So, we're going to start with this right triangle. Notice in this picture, the right angle is actually at the top. And you guys, this is our 45, 45, 90. So obviously we have our 90-degree angle here, but in this particular type of triangle, both of the other angles are 45 degrees. So if you have a triangle that has a 45, 45, 90 angle structure, I know even more than just the Pythagorean theorem tells me about a problem like this. I know that if we wanted to call one of the legs x, that this second leg would also be x. I'm not going to go into a lot of in-depth proving of that fact, but something you do probably remember is that sides and angles of triangles are related. So the smallest side of a triangle is always going to be opposite of the smallest angle. The largest side of the triangle will always be opposite the largest angle. Because of this relationship, we know that if both of these angles are exactly the same, that both sides that are opposite of them will also be exactly the same. So if you know the value of this leg, we're calling it x, then you know the other leg is also going to be x. The question is, how does that relate to the hypotenuse? So I'm going to do a little Pythagorean formula for you, and we're going to find out. So I know I have the a squared plus b squared equals c squared. I know it works because this is a right triangle. Let's put in our leg values of x. So it'd be x squared plus x squared equals, I still don't know the hypotenuse, right? That's what I'm looking for, so I'm going to leave that as c squared. So I'm looking for a way to write the hypotenuse in terms of x. So look, x squared plus x squared, because those are the same variable, I can add those together, right? This becomes 2x squared equals our hypotenuse squared. I'm trying to find the hypotenuse, so let's go ahead and square root both sides. When I do, be careful, when you're square rooting a term that has both a number and a variable, remember to square root both of those things. So first I'm going to take the square root of 2, which I'm just going to write as the square root of 2. Then I can take the square root of x squared, which is just x. So I'm going to write that as the square root of 2 times x. That's what's left over here after square rooting. What's left when you take the square root of c squared? Well, you get c. So what this means is that if both of your legs are x, then your hypotenuse can be written in this way. It can be written as x times the square root of 2. And I am going to write it with the x in front, because when you're using handwriting, and like I am obviously in this lecture, it can kind of be confusing about where this particular root stops. Is it over the x? Is it not over the x? I like to just cancel that confusion and put the x in front. So for the 45, 45, 90, if both legs are x, your hypotenuse can be found by taking that x value and just multiplying it by the square root of 2. So let's do a quick example of one of those special problems. Okay. Right here, I've got a problem where we have a 45, 45, 90, so this looks very similar to your homework problems. It tells me that one side is C, and I also know that the hypotenuse is 3. So, you guys, my goal is to find out what this C value is, and also use my knowledge of 45, 45, 90s to say that, oh, well, this leg's going to be whatever I find for this leg, because they're exactly the same. But look at this. All we have is the length of one side. If this was not a special triangle, the Pythagorean theorem wouldn't work because I don't have two sides. Usually I have to have two so I can find the missing one. But in these special cases, I really only need one side because I know their special relationship. So let's get started. In the 45, 45, 90, the hypotenuse is labeled as x root 2. So I can take this 3. I know the hypotenuse is 3, but I can also write it as x root 2. My goal here is to find x. Why? Because x is the length of these two sides, right? So x root 2 equals 3. I'm solving for x. I need to divide both sides by the square root of 2. So when you get x by itself, you get this 3 over the square root of 2. Now, before we go to our calculators, we need to look at the wording in the problem. So you'll see when you're doing this homework that it wants exact answers, which means I have to leave the roots. So you might say, oh, okay, this is my answer for the length of x. But you guys, we never, ever write an answer with a root in the bottom. It's bad form. Sorry. So you guys, I have to get the root out of the bottom before I can actually submit this as an answer. I can't change the answer, but I do need to rewrite it to where the root's not in the bottom. What we do is we rationalize the denominator. That's our goal. Why is it called that? Well, because the square root of 2 is irrational, right? Any square root that doesn't end up being a perfect square is an irrational number. That's what makes this a problem. We can't have an irrational number in the denominator, so let's make it a rational. Let's rationalize it. It's real easy to do, and you guys, we do this so much in this class, you get so used to it. all I have to do is take that square root I'm trying to get rid of and multiply the top and the bottom of my fraction by that square root. Notice, because I'm doing the same thing on the top and the bottom, I'm not changing my answer. It's like multiplying by 1, right? But what happens is on top, I will have a square root, and that's okay that it's on top. I'll have 3 root 2. And on the bottom, the square root of 2 multiplied by the square root of 2 is 2. It's like saying the square root of 2 squared, right? So you end up with just a 2. So this is my answer. This is x. Remember, x is the length of both of these legs. So your c in this case would be 3 root 2 over 2. I don't think it asks for the other value here, mainly because it's the same. But if it did for some reason ask for this other leg, you know it would be exactly the same value. Okay. So all we did was we used this relationship in x to help us find the answer here. So that's what you're going to do on those problems. But we do have one more special right triangle to deal with. We have the 30, 60, 90. It's another special case of right triangles. So let me draw one out for you. I'm actually going to draw it this way. Oh, that was great. Okay. So you guys, we have your 30-degree angle up here, your 60 down here, and obviously this is the 90. The way these x's work out is a little bit more complicated than the way the 45, 45, 90 goes. So I'm just going to show you the side relationship. We're going to start with x, the bottom leg, not necessarily the bottom, the shorter leg, we'll call it that. The shorter leg is what we're going to call our x value. And if the shorter leg is x, then in this particular case, the hypotenuse will always be double the shorter leg, so it'll always be 2x. You guys, the long side is always going to end up being x times the square root of 3. It takes a little bit longer to explain this particular relationship, so I'm just going to leave it at that. If you are very curious about it, I'm sure Alex can tell you all about why this is the case, or you can talk to me in office hours and I can explain it there. But for the sake of time, we're going to trust that this is the relationship between the sides of the 30, 60, 90. So let's use this relationship to answer a question. So I'm going to draw it the other way. I want you guys to get used to seeing the triangles being oriented in different directions. Making sure that you can always pick out which are the legs and which is the hypotenuse is really important. So in this example, hold on. Okay, all we know is the hypotenuse is 5. So your goal in these triangles is to take the side that you know, compare it to the side in your relationship written in x's, and solve for x. If you know x, you know every side, right? Because each side is some version of x. So what I know here is that the hypotenuse is 5. I know the hypotenuse in the 30, 60, 90 is equal to 2x. So if you take your 5, set it equal to 2x, all we have to do is divide by 2, and we've got x. You guys, so x is 5 halves. Remember, these answers are exact, so I'm just going to leave it as a fraction. All right, so I have x, which means I know the length of the short side because the short side is x, right? So I can say that the short side is 5 halves, You could write that as 2.5. That would still be exact. I think it would take either value. But over here, I need the long side. Remember, that's the x root 3. So how do I take x and then write it as x root 3? Well, let's see. X root 3 is the long leg. Put in the x, and we get 5/2 times root 3, which doesn't look great, and it looks a little bit complicated, but remember, your answers here just have to be exact. So what I'm going to do is I'm going to recognize that this root 3, I could write that as root 3 over 1. This is on top of a fraction, right? So you can put it on top with the 5 and get 5 root 3 over 2. So 5 root 3 over 2 is the length of your long leg. So we found the long leg and the short leg just by knowing the hypotenuse. So you guys, this concludes the geometry review, basically just everything about the Pythagorean theorem. And my next video, we will start into the actual trig coursework. We're starting with section 5.1, so be on the lookout for that. You'll notice that in ALEKS, your homework doesn't necessarily have due dates. So obviously it does have a due date. It's just the last day of class. So it's more self-paced. If you want to work ahead on your homework, maybe you took trig in high school or something, or you just pick up on it really fast. You can work ahead as far as you want. We will have set quizzes and exams at certain times that you can't work ahead on. You have to just take them when they're open. But the homework is open totally for you. All right, so other than that, that's all I've got for this video. I look forward to having you guys in class, and I will see you for the next video.